Pranav, sir,
Yes, ma'am.
please begin, sir.
Yeah. A very good afternoon to one and all. I, Pranav Chipalkatti, on behalf of JSPM's Rajarshi Shahu College of Engineering, Department of Electronics and Telecommunication, heartily welcome you all for the third session of Day 6 of Phase 2 of AICT-sponsored 2 weeks faculty development program on artificial intelligence and its application in biomedical engineering. Today we have with us an eminent speaker, Dr. Sandeep Wankhade sir, to deliver session on topic TRIZ Roadmap to Innovation. On behalf of ENTC department, I heartily welcome you, sir. I feel extremely proud and honored to introduce him today. Dr. Sandeep Wankhade sir is working as an associate professor and head at Department of Production Engineering at AISSMS College of Engineering, Pune. He is a chairman TRIZ Chapter Pan India and TRIZ Association of India. He is also an evangelist and consultant at TRIZ Asia. His areas of interest and research are education management, EDM, TRIZ, mechatronics, Industry 4.0, and new product development. He is pursuing his postdoc on efficacy of TRIZ tools on creativity of an individual, sponsored by TRIZ Association of Asia and GenTRIZ, Boston, US. He pursued his PhD in 2017 in mechanical and production engineering from SRTM University, India, and completed masters in 2001 from in manufacturing technologies from Thapar University Institute of Engineering and Technology, Patiala. He completed his bachelor's in engineering in 1994 in production engineering from Amravati University. Sir has a couple of certifications. One is the TRIZ Level 3 Matrix US, and another is the Six Sigma, that is Learn SS Black Belt certification. Regarding his grants, he has received grants for 1 national level FDP, 4 state-level seminars, 3 research projects, and 1 laboratory development, that is metrology and quality control. He has a total of 24 years of experience and is involved in training and consultancies at various multinational companies like Bajaj Consumers, Crompton Greaves, etc. He has judged and groomed participants for various competitions like Avishkar, Smart India Hackathon, Sparkle of KIT, etc. He is a coordinator. He has coordinated various projects and extensively guided projects on automation, Pokayog, process development, cost reduction, Kaizen, 5S, new product development, and vendor development. To his achievements, he has a patent published named Solving a Social Problem by TRIZ, that is Theory of Inventive Problem Solving. And he has also is also a topper among 785 certified participants in the course conducted by IIT Kharagpur and NPTEL on the subject Introduction to Industry 4.0 and IIoT. He has stood second in the state level research convention Avishkar 2018. He has been felicitated at SPPU for contributing in winning overall trophy in Avishkar 2018. He has developed 3 innovative mechanisms and published 14 research papers. He has delivered 50 plus invited lectures at international and national levels and has contributed to Industry Education Partnership Cell of Government of Maharashtra. We are fortunate to have you with us, sir, today. I now request you to please start the session. Thank you, sir.
Thank you, Pranav sir, for these big words about me. I hope I am audible.
Yes, sir. Yes, sir. You are audible.
Yeah, and screen is visible.
Yes, sir.
Yeah. At the onset, I would like to thank you, Pranav sir, for saying so high words. I don't know whether I'll meet the expectations of the audience or not. And secondly, to JSPM for inviting me again for delivering this session. And today I'll be speaking on TRIZ Roadmap to Innovation. I'll try to keep it live with the chat box. If anyone have any question or any suggestions, I would request them to just share it with me, and let's have it a bit interactive. So is there anyone who is knowing about TRIZ? A quick question. You can just chat it or unmute yourself and let me know. No. So All are faculty members, right?
Yes, sir. Yes.
Okay. So I got one answer, and I take it as a representative of all that people don't know about TRIZ. So it's my duty to let people know about this wonderful tool with which I'm fascinated since last 5, 6 years, and I'm trying to learn more and more about it, and obviously share it with more and more people. So today uh, on this HTTP on artificial intelligence and its application in biomedical engineering, I would like to share my views on innovation with the TRIZ tool. So uh, because most of us are from education, so I would just like to directly indirectly be everybody in this nation is connected to education, and recently our prime minister has launched very much awaited new education policy, and with the view of that, like earlier, if any problem is there in a society, so it would be having some background, some kind of experience people used to have, and based upon that experience people could solve those problems. But now the society is rapidly changing, and in that way, thanks to COVID, because it has made us do so many things which we would not have done in next 5 to 10 years also. It has completely disrupted, as well as it has completely renovated the education system, and we are very much familiar and convenient with the online. So these changing society is posing some different problems which were never faced before, and we need to generate solutions that were not existing before. So we do not have any kind of references to what kind of problem are these and what kind of solutions it could have. But then we have some tools, and these tools will save us and will let us sail in any kind of turbulent sea or water. So in education, it is high time to introspect ourselves. Like we understand that education model in its current state is not going to help students solve the problem of the nature which were described earlier. And current challenges are to solve the problems which are never faced before. And even NEP says we have to shift from what to think to how to think. So let's see how this TRIZ tool would be useful for us. Before that, I'll ask you another question. You know whose photograph I put on, the great inventor Thomas Edison. May I know for which invention he is known for and how many inventions he has got? I would appreciate if you become live and keep on chatting and keeping your views on the chat box. It will also help me to like deliver the session according to your requirements. So there were 1076 patents, one answer I have given, but let me know for which invention he is known most. I'm waiting for your answer. Okay, I'll give you the answer. It is bulb, because most of the time whenever I have asked and whenever people responded, I got the answer bulb. Do you agree with me? I again assume you agree with me. Okay, so basically bulb was not actually invented by Thomas Edison. Some of you may be knowing it, and some of you may get surprised by knowing it, because it is innovation and bulb have become now kind of synonym. So whenever we want to represent with a pictorial view something, an idea had come, an innovative idea had come, so we just show the bulb over there. But there were many people who actually tried making a bulb, and the phenomena was known to them. But then why Thomas Edison got the patent and why he was known for this invention? Because he converted into a product. It is not enough to have a product which is not saleable. So when I say it is product, it means that it has got some reliability. It will work, function for a set duration of time. It may be years together or maybe a few months, but whatever it would be. So a customer knows for what duration it would be work. There are many things which are use and throw, which have a very short life, and they are designed in that way. So all said and done, if I'm spending some money from my pocket to buy a product, I must get an assurance that this product would work. So similarly, when Thomas Edison make this as a product, it reached to the household, it fit to the pocket of the customers, and then it became a product of everyone. and that is why he was known, and that is why he could get the patent. Now, what exactly did he do different from others? The principle was basically, if electricity moves towards a metal or a resistive material, it actually heats it, and this heat actually illuminates it. It makes it glow. So, but what happens if we do not have a controlled environment, and if there is a oxygen over there, it will quickly oxidize and bulb will be no more. It will be just finished. So he made trials, and you know how many trials did he perform before making it as a project product? So there were 6,000 plus experiments. Yes, unbelievable that one person can perform so many experiments. All said and done, he was not alone. He had a giant lab, and he had many people working for him, in his innovation lab. But then 6,000 experiments is too high. We were actually born with, or brought up with, the statement that genius is 1% inspiration and 99% perspiration, means hard work. So if you want to innovate, if you want to invent something, you have to put a lot of hard work. And Thomas Edison is not the only example in that. Even you might have heard about Goodyear tires, you would have heard. And Charles Goodyear was the person who actually vulcanized the rubber and made the rubber useful. But you know what? He spent his entire life in doing it. And it is saying that if someone goes to find Mr. Goodyear, and if he asks in his neighborhood that where would I find Mr. Charles, so people used to say, you go ahead, and in that workshop, if you find a person, rubber all around his body, and he would be adding anything and everything to that rubber. So you will find that this is the person Charles Goodyear. So what did he do? Right from soup, right from cotton, right from whatever was there, he kept on adding in the rubber. And one fine morning, he could actually made a vulcanized rubber. And thanks to him, thanks to Edison, that today we are having such a good, wonderful life. And bulb is not a bulb only for glowing. And in fact, that bulb has gone, but it has initiated so many things. And I need not speak more on that. You realize it very well. So this is like a turning point. Actually, what is it? If we look at his second invention, yeah, another invention, not second. So it is nickel ion battery. Today, if I'm working on my laptop, I'm using my mobile or whatever I'm doing in this era, the battery is actually an integral part of our components, like appliances, whatever we are using right now. So that is again a huge invention. But then what? 10,296 experiment. Do you really think someone would put money if you say, give me, I'll try it and I'll make it successful, but pay me for 6,000 or 5,999 wrong experimentation? Do you think someone would put money on you? So same thing. Me and you are very small. We do not have any existence, in fact, to say anything about Edison, but we all know Nikola Tesla. So you know him for what? You can put it in chat box. But once he stated that uh, it was always sad watching Edison working, knowing that just a little theoretical knowledge and a few calculation could save him at least 30% of his time. And during that time, people also realized it. They realized that whatever Edison is doing, he is just adding like more and more manpower. He's charging more and more to people. He'll make it successful because it's once he get down into certain things, he'll put his all efforts till the time he finishes it. But again, according to again Nicola, he said like if the knowledge of mathematics and basic sciences would have been applied, he could have saved a lot of time, and he could not do this. And there are different stories about Edison and Nicola. I will not go with that. So coming to needle in a haystack, this is considered to be one of the biggest challenge in mankind. Again, like bulb and idea, it is a hard work or like a difficult work. And finding needle in a haystack has again become a synonym. So let me know, if you have to find out a needle from this haystack, what would you do? Okay, you can just put it in chat box. Meanwhile, I'll let you know what Nikola Tesla said about Edison, that if the same task would have been given to Edison, what he would have done with the diligence of a bee, honey bee, he would have just started without thinking anything and just move one straw by other. haystack is like a stack of dried grass. So he'll just keep on moving one by another grass, and till the time he find the needle in this haystack. There are two chances to get it. One is that the needle will lie somewhere on the top of that, and by luck Edison will find out. Or the other way is that the needle would be lying at the bottom of this haystack, and by his hard work again Edison will find it out. Are you getting it? But alone Edison would won't be able to do it. So what he'll do, he'll employ more and more people as bigger the size of the haystack, and he'll charge the customer for finding it out. Are you getting it? So if the same problem would have been given to you, what you would have done? How many people you would have employed? Can you just tell me? Please be reciprocative. I'm waiting for your answer. Very simple answer. If you have to find out this needle in the haystack, how would you find it out? I hope I am audible. Pranav sir?
Yes, sir, you're audible.
Or it is like only I am audible to you alone. I hope it is not like that. Anyways, I'll go ahead. The simplest example or simplest answer which I would have ever got is magnet. Let me know. Till that time, I'll explain you another thing, like what is today's innovation landscape. Our methodology of TRIZ basically minimizes risk and increases innovation effectiveness. You can see this graph, and you can see, just a sec, you can see that this is the impact of result, this is likelihood of the result, and incremental and breakthrough. You know what is incremental? If something is to be developed, we may go by some baby steps. We'll keep on adding some features in that and see whether market responds to it or not. And if market responds to it favorable, we'll add another feature, and likewise we'll keep on going. So what it will do, it will give us the very high likelihood of results, good results, and people will appreciate it. And that is why innovation is rewarding. But incremental consumes a lot of time. What if I come up with all these features directly into the market? Yes, it will save a lot of my time, but at the same time, it will be risky because I don't know whether the customer will like it or not. And you have a many number of very good products which have failed in the market just because of some of these reasons. Can someone give me an example? A very good product, ultimate product, wherein hundreds of patents are being actually like used, patentable technologies are being used while making that product. Hundreds of patents, around 600, 700 patents were made, filed and published also. Anyone? Okay, I'll let you know. It is Nano. Is it being seen? No. It was a talk of town when it was yet to be launched. Even when it is launched, it is a marvel of a product. It is a wonderful product. It fits in the pocket of many. Okay, but why didn't it survive in the market? Any idea? Why this is not being accepted as a product, in spite of being, even forget about others. Mr. Khatta, who is a MD of this Maruti, he also appreciated. He also said many good words about that. Everybody was aware about the product, but it had got, even Mr. Ratan Tata has accepted it, that it was marketed wrong. Because whose car was it? What had the label attached to that? Poor man's car. Car developed for a common man, poor man. And would anybody like to get himself called as a common man or a poor man? No. What people used to do or are still doing, they are just buying second-hand car in the same rate, or rather in a higher rate than this Nano, but they are not going to buy a car, because moment you drive a car, moment you have this car, people will label you as a common man or a poor man or a middle class family, right, Mahendra sir? Are getting it? So just this one notion, that's just get this kind of one factor collapsed everything whatever had done in the Nano. Just you go in some Google it, how nano is developed, what are the developments and what are the innovations in nano are there, you'll be less like think like how crazy these people would have been and how could they do so many things. But what happened at the end? It failed. Now what would we do? Had it been an incremental, people would have got an idea. Okay, people are considering nano as a poor man's car, so let's leave it. Let's not go with it and have some different direction or something like that. But it was directly launched, and then the Tatas realized that it has got something wrong associated with that. So, what being an engineer, I would do is have a best of the balance between these two and find out the best average or mean, something like that. But what TRIZ would do? TRIZ will just have this innovation risk move towards innovation in reward. And in this way, you will be just, it is not a question of only one product. There are many, many more products you can just think on. You can just find it out. And these have just not, are miserably failed in the market. I won't say not successful, but these are miserably failed in the market. Okay, in spite of having such a good product and affordability and everything. Okay, so what TRIZ basically do and how does it solve the problem? Everybody has got some problem and the solution is available. So now what is required? Solution is to be found out. And for finding out the solution, who stops? The mental inertia stops. From where this mental inertia comes, it is in our mind. We cannot stop it. And TRIZ gives us a method. TRIZ gives us tools to reduce or eliminate this mental inertia. So now what happens? You get steps and directly you are able to reach to this solution and you overcome the mental inertia. You means whosoever learns TRIZ. Okay, I don't say without TRIZ problem cannot be solved, but this is a structured method and can work on in a step-by-step method and guaranteed to be delivering the solutions. At the same time, it is repeatable. It is not a kind of fantasy which has worked for one and is not working for another application. It is you can practice it, you can teach it, you can learn it, you can repeat it. Everywhere TRIZ will work for you. Okay, now if we go back to the innovation kind. Okay, we have an idea. From idea, what we have to do is just jot it down. What is it? We define that idea. Once we have defined it, we try to test it and different parameters, whether it will work like on customer basis or on practically the spare parts, would it be available, like manufacturability and so on and so forth. Many things would be there. And once we find that it will work on that, then we go to design it, then we go to brand it, then we get it protected through patents, then manufacture it, and then launch it and sell it. Okay, now what happens if you have, and it is a study, okay, if there are 1250 raw ideas, so out of them only 14 get success. And this is also a bigger number nowadays with the advent of many other methodologies and simulations and rapid prototyping and all that stuff. Earlier it used to be for 2500 plus ideas would have resulted only in 1 point a few, means you can consider only 2 successful products. So what we do whenever we use other methods, so there are divergent thinking. What this divergent thinking does, because I want successful product, so I should have more and more idea. That is why what we do, we create choices, we look for more and more ideas, we have brainstorming, we do different lateral thinking, then systematic innovation thinking, then there may be like design thinking. There are so many ways in which it is being done. I just don't want to demean any of these other processes. I just want to speak about TRIZ. Okay, so here we intend to create more and more choices, and once we have plenty of choices, then we start doing, okay, how many of them would work on as an screening, and only 68. Business analysis says that only 47 are worth of going ahead. Development says only 33 are worth of that. And in this way we filter them out, and while we are filtering, we are narrowing down to the number whatever we want or which we should approach to. So ideal value would have been that you want one solution, and for that, rather, you have a problem, and for that you need a solution, and for one problem you should have one solution straight away. But what happens, But practically it does not happen like this. Practically what happens, if you have one problem and you want it to be a solution, this is what you want, you have to sieve it down, you have to filter it down from such a huge number, and then you see this is so small and hidden in very big other things which are just encapsulating it and very difficult to find it out, filter it out like this. But what this does, it actually narrows down while it is creating the choices, and it diverges when it is making the choice, exactly opposite to the traditional methods. And that is why we get workable number of, yeah, rather multiple solutions for the like innovation which is successful. Okay, what is TRIZ? So again, if we want to understand TRIZ, we need to understand like what is mental inertia. So you can just see, after, of course it is a cartoon, but then this fellow is trying to fish, but there are so many fishes, he just need to turn around, but his mental inertia is not permitting him to do that. Okay, so similarly, when we go with other methods of finding the solutions, these are all trial and error methods, and it is again found by research, by survey, that many a time when you try to go with trial and error method, you can get the solution. I'll give you example also how you can get the solution from trial and error, and that would be a right solution. And how would you get it from TRIZ? But at this point, most of the time we tend to move in the opposite direction. We go over here, realize it doesn't work, then we go in this direction, this doesn't work, when we go in this direction, doesn't work, come back, go over here. But TRIZ quickly takes us to a narrow zone of working solution, and again very quickly we reach to the most ideal solution which has got maximum value, that means lowest cost. Okay, so this strong mental inertia drives us away from the right solution direction. You can just see this fellow is trying to find out this needle, and he's just searching over here. But if he just takes a round across the different domain, I'll explain how these different domains are there with example. So he could have reached to this needle and quickly found it out. Okay. So problem solvers must overcome minimum 3 of the 16 available psychological inertia. And what are those 3? You just see terminological inertia, image inertia, and inertia due to function orientation. Again, I need your help to answer some of the question. If I say fan, okay, so what do you look at? If I say a fan, okay, if not a fan, if I say a knife, what do you look at? How does a knife look like? You can just chat. Do you see anything other than a sharp edge and a handle to hold it? If yes, write yes and say what you see, or you just say no at least. What is a knife? Yeah, holding capabilities and having sharpness. Is that all? Now what, when we think of with a, see these 3 things are there. What is this? Terminological inertia, image inertia, and inertia due to function. What did I say? Knife. What do you see? A handle and a sharp edge. Okay, holding on that, which can cut it. And what is the inertia due to functional orientation? Functional orientation is that knife is to cut vegetables, and for doing that, you just imagine what image comes to your mind is you are holding something like an apple in your hand, and then you are cutting it with a knife. But do you think there would be something different from this? So if you cannot think, this is our like mental inertia, and if you are not answering it, I don't know what kind of inertia is it. Okay, capable to cut as a tool, yes. But when we speak the same thing with TRIZ, we say that knife is a tool. Why do we need this tool? We need this tool to make 2 parts or multiple parts. Initially, at one point of time, we will be making it 2 parts, then gradually again 2 parts, and likewise, it will be cut into small pieces. Right? You can have multiple of them kept aligned and cut it in the same stroke, and all these innovations we keep on doing to cut the vegetable fast. But there are many things which may not look like a knife, but still are performing of cutting, yeah, separating. We will generalize it and say it as a separate in TRIZ language, separating the two parts of the apple or the fruit or the vegetable, whatever we want to cut. Do you think even a food processor, a mixer, is a knife? What do you say? Then there are some instruments nowadays which are coming, since long they are coming, like some kind of like a shapes are there, and you just need to put the um, part of a fruit or some vegetables on that. Particularly it is used for salad, and when you press the upper part of that box, there is a knife like sharp edges which have some shapes, and then you get some particular shape of that salad directly in the thing. Like there would be a container. I do not have this image with me. I'll show you, and you can just Google it and you can find. And most of you must be knowing it also. So it is like, yeah, it is a food processor. So basically, when we look at it, this is the inertia, and we just tend to work on that. This is just a symbolic example with very small thing, but whenever we look at other things also, let it be a fan, let it be a bicycle, let it be a anything which you look in front of you. So we already get associated with that. I'll just give you 3 methods to overcome this. So to break this physical, psychological inertia, there are 3 things: ability to see links between phenomena and object, ability to analytically think, and ability to fantasize. Now, what is seeing the link between the objects? I'll just show you that. What is this? I don't know why you all are not reciprocating. More you reciprocate, more you will be enjoying the session, except one person. This is a lamp, this is a light, perfect. What else? Okay, if I use it, what are the problems associated with it? Yeah, perfect, fuel to light. If you use it, what would be the problem? Perfect. There is a shadow at the bottom of light. Perfect. Actually, yes, it will not illuminate everywhere. It is having a limited illumination capability. I just consider that this is lamp is being used for some kind of. There are several reasons. One of the reasons would be to decorate. And Deepavali has just passed, and we decorated this lamps everywhere in our house. But what are the problem associated with that? There is oil. It is where that oil gets consumed. It finishes. We need to refill it. Oil is very sticky. People don't like to use it. Then we need to devise something, do some innovation, and have some container which will not soil our hands, and still we will be able to do it. But still, we have to keep on refilling. Second, this may fall down. This is slippery. Someone may also fall down due to just slipping. Then it is this oil goes up through this wick. This wick also gets consumed, and then again you may have to replace it. Then there would be a fire. Okay, if something comes in the contact with this, what will happen? The person or the cloth or the curtain, something may catch fire, and it emits smoke. Okay, so there are so many problems. If this entire lamp fall down, it is brittle, it will break. Okay, this will just get toppled when we are moving. And there may be much more. More you think, more problems you can list out. Now just let me know what is it. And did it solve those problems? Phenomena is change. Earlier the phenomena was that the light was emitted due to that wick and the oil, and now this is an electrical one, and all those problems which I listed, mentioned, have gone out. Okay, yeah, it is pool of resources, but you can see some wires, and these are all electric one. But at the same time, someone may come up like, why were we using lamps earlier, and why that was beneficial? So there is also something known as an aromatherapy, and that is why you might have found that in many temples there are hundreds and thousands of lamps being lighted, and they use some pure oil and typical oils, different kind of oils. Okay, means extracted from different raw materials or grains or whatever. So these have got its own importance also. And when I just try to find it out, like aromatherapy and all that stuff, I just happen to, if not for this, but even we have lamps in our house. Okay, so there are some rings which emits some kind of aroma or some kind of scent when it is put on. These rings are, can be put on the bulbs at the bottom base of that bulb, and generally the base gets heated, and due to that heat this aroma actually spreads over, and you can see the previous advantages whatever were there can be attained by some new phenomena in that also. Are you getting it? Earlier it was due to the ingredients of this oil. Now it is due to some ring which may be put across this, and due to the ingredient kept in that ring, the same thing can be achieved. So anything can be achieved with a different phenomena. That is what I wanted to tell you. I hope you like this answer or example rather. Ability to analogically think. So when you might have seen birds flying, this is a very common example, and they have some pattern, and even aircraft, okay, also follow them. So what do? Without making any changes in aerodynamics, any shape or any material, nothing changed, just by having a certain pattern in which they can fly, lot of air resistance is reduced, and you get without any much cost the advantages of aerodynamism. So just see, analogically we can do it. Third thing is ability to fantasize. Let me know what is this. Can you answer what is this? I'll just put it on bigger screen if you cannot see it properly. So what is this? Yeah, learn from nature, further love. Yeah, it is unbox. I like it, Mr. Mahindra. So basically, if you ask this question to a grown-up person, he'll just simply say, "Oh, it is a box. What is so special to ask about it?" But the same question, if you ask to a kid, he can make certain things. He can just fantasize a fort, a house, a car, a castle. So many more things he can think of. Now, you may think that it's okay. Like, what's so great in that? But I just listed out some of the results of fantasizing. Robo. It was not designed or actually coined by or like envisaged by some person who was a scientist. It was by a Czech playwriter, that is Karel Capek, and he had titled RUR. There is a very interesting story, but because you people are not answering my questions, so I'm not going to share this story with you. Of course, you can Google it. I cannot stop you from doing that. Second is like, what did it develop? It developed a robo. This was the first view. And today, if someone thinks about a robo, that is not something like surprising to us, but it was a fantasy at that one point of time. Similarly, Submarine, Jules Verne, 20,000 Leagues Under the Sea was the novel. And in this, it was done. And Nautilus actually was the name of the ship, and it was developed. Frischmann inspired and shaped it. Cell phone. This is something which we are using day in, day out. You know what? Important thing. When there was a Star Trek, it was a serial which used to come on the TV also in India a many time years back, and Martin Cooper just thought of from that, okay, can I have a communicating device like this? And just in 90 days he made it. Okay, I don't know what it is, I'll explain you later. Okay, this was the one which was shown in Star Trek, and this is the one which Martin Cooper actually made. See the time, 19 days. So what is stopping us from fantasizing, stopping us from developing an idea and believing that idea? That is the most important thing. Okay, so it is also said, like, if you want your children to be intelligent, read them fairy tale books. If you want them to be more intelligent, read them more and more fairy tales. And that is stated by Albert Einstein, which because it empowers them to fantasize, it empowers them to think in a different aspect. Okay, so now coming to the founder of TRIZ, Gedrick Altschuler. He was with us since 1922 to 1998, and he did a lot of study on global patent collections. And he was a Russian engineer when he was in school. At that time, he filed his first patent, and then when he was graduated, he like participated in one of the competition of Russian Navy and solved one of the problem in which it was expected that a person who is in submarine should come on the surface of the sea quickly in case of the wreckage, in case of the accident. And the condition was, while he was working, that fellow was working in the like a submarine, he should not have many things put on his bodies. So that should be minimum harness on the body, but it should take minimum time. Again, if something goes wrong, he should get something which will protect him from the sea, and such a, like he would when it is a submarine, one person would be down below the sea water, and to come down up to the surface of that, there should be something which will take him quickly and safely. And he did it. In turn, he got a job of a patent attorney. And when he became a patent attorney, he was a kind of a different person, and he kept on observing, and he found that there are 5 levels of invention. He defined the inventive problem and the patterns of technology evolution. We'll see what these are. Okay, so what he did when he was a patent attorney, he went through around 2 million patents. And when he went through these 2 million patents, he realized that 40,000 of them are actually the breakthrough inventions. And what does he mean by breakthrough invention is the inventive problem definition. I'll just share it with you. And literally manually he sorted out all these 40,000, and then he made some knowledge out of that, and that is what is TRIZ all about. So what were his key discoveries? That 99% of the creative solutions use already existing solution principle. Do you know, only 1% of the problem are not solved. Now, how does it happen? Why do we face so many problems? Because again, our mental inertia or a lack of reaching out to the solution quickly, because there are only 1% of the problem in the world which are not being solved, and these are the solution problems, and the solutions to it are something like one would win a Nobel Prize. So where are these? Okay, so he says that there would be 99% which are solved. So new innovative solutions can be produced in a systematic way by reusing the previous experiences. Okay, and a breakthrough solution most often results from overcoming a contradiction. Now, what is contradiction? That I'll explain later. Inventors and strong thinkers use common patterns. So let it be in any domain. Okay, so different domains, still the inventors will think in the same direction, and that is what he did. What he did is, like, he sorted out these 40,000 patents, and he thought like what problem this fellow has solved. And when he studied in detail, then he sorted it out in certain different engineering parameters. And once he did it, then his next question was, how did he find the solution? And he listed them in 40 inventive principles. And today what we are going to do is we are going to learn those 39 like engineering parameters and 40 inventive principles, whatever has been derived by Altshuler. And not only that, if you all cooperate, we'll also solve a real life problem with that. Okay, so this is all about its key discoveries. What is the problem solving approach? Okay, this was a car, and initial car, you can just make it out from looking at it. This is a steering. This used to be all mechanical, and we just assume that this is a problem. This steering would have some problems. So problem were there, there were solutions which can be found out and which can be sorted out. But if this problem is somewhere, or sorry, this solution is somewhere beyond the reach of that knowledge level. Okay, this is a problem area knowledge by which this is developed. So even Einstein stated that if you can solve the problem with the same, like you cannot solve the problem of a system with the same knowledge, problem area knowledge, because if you can solve that, then it would not have been there at first place. You have to go beyond that, and that is the domain knowledge. And domain knowledge means this is a mechanical transmission. So in mechanical transmission, there are different type of joints, and people found out this, and they made it easier and simpler and more efficient, more easy for a user to work on, and this solution was met. But again, the human demands are excessive, because we need to drive like a bigger and bigger truck, and we don't want our muscle power to be used for turning a vehicle. So solution is beyond this. We need to go in all possible knowledge. And what is the all possible knowledge? Go beyond that mechanical, and you can go in power steering.
So I hope all of you must be knowing what is power steering. Again, if you don't know, you can Google it and you can find it out. Most of the cars whichever we drive nowadays have power steering. It works on the domain of either electric or hydraulic and pneumatic. Not much of pneumatic, or not at all of pneumatic, rather hydraulic and electric. Okay. So we have gone in the different domain, but still if someone has got some problem, so it has to be solved and you need to go in. Actually this is like impossible knowledge for all these domains. And what do we have? We have still the solution, but then we have drive by wire, and in this case there is no steering actually required. Probably tomorrow autonomous car would come and it will not have any kind of steering. You just sit on that seat and all those motors would be directly mounted on these wheels, and all these four wheels may be turned in directions. Today also people tried it, but because controlling of these four wheels in the moving in different direction is very difficult, that is why only one way it can be turned. You can just think of, like, if front, even if we have two wheels moving in two different direction, what would have happened, right? So these all controls can also be done, and very soon you will be finding e-cars, autonomous cars, and then instead of this type of tires there would be ball like tires, and which can move in any direction. And then right now also people are trying, if I'm not wrong, I don't remember the name of that company, but Mercedes is working with one of those tire making manufacturing company. Most probably it is Goodyear, but I'm not sure about it. So these tires are in like trials, it is going on, but the problem is that controlling them becomes difficult. And as I mentioned, people don't want to use their muscular power, so they do not need to use their skills also, and they just want a safe driving car. And now you have cars with lidars and radars and everything. Okay, so let's go ahead. I'll give you one important tool. You can use it everywhere. Only thing which will stop you from getting the good solution out of is your, I don't know, I should not use it, but if you do not use it, you won't be able to work upon that. That is the only thing which may stop you from getting the solutions. This is the type of fields used in TRIZ to solve inventive problems, and Altshuler found that this MATChem IB. So MAT is what? A short form of, full form of M would be mechanical, A acoustic, T thermal, CH chemical, E electrical, and if we can connect these two, electromagnetic, and most of the things which are there in automation today are product of result of electromagnetic field. And then intramolecular information and biological. If you feel that magnetic is being used only in engineering examples, so I've just listed out one of the example, and this is magnetic eyeliner. This lady, she was just sitting in her car and she was not able to put on her liners, lash liners, or what exactly. She just thought like how I should have a quick way of doing it, and she thought of the magnetic way, and just in an year she has become a multi-millionaire. So everything, as I mentioned, you can just Google it. You can just find out lash liners and liners and magnetic eyeliner. There are many now, but the pioneer always get the advantages of that, and that is why we should catch the bus when it is. It starts from the like starting point. This is another example of biological. Our body is actually having someone just Mahindra sir said that learn from the nature. So nature also have all the provisions. You know what? This finger is actually pruned. That's what when you put it your finger in the water for a longer duration time, it becomes like this. Why does it become like this? Because if there is lot of water, there would be chances of less friction and slipping down. So body by itself create some more surface area so that a person will not fall down. Same biological concept can be used and is being used in many industries, applications, and researches. Okay, I can share some of the name of these websites wherein you can find these very interesting examples through this. But for that you have to ask me, and for asking you have to start using chat box. Coming back to using MATChem IB field, as I mentioned that what is the way of finding out a needle from a haystack. So one is this magnetic. Now let's go back and ponder on what is this mat chem IB. M stands for magnetic. What are the other ways to do it? Can we find it in an acoustic way? Okay, so there would be a metal detector which will release some acoustic waves, and these ultrasonic waves will go and hit that needle and come back, and you will come to know the exact area or the probable area, as I have shown you in the first graph. If you remember that trial and error, and second side it is like the TRIZ way. Okay, so you can just reach to it. Now again, don't ask me whether all the like metal detectors are made by TRIZ. No, that is not important. You need not invent every time. You need to understand that there are 99% of the problem which are already solved. What I need to do, how it is solved in other domain, same way I want to solve my problem in my domain. Okay, so this is one way. Actually, when we define it with the TRIZ language, we do not say how to find a needle from a haystack. We would say it as separating needle from haystack. Are you getting me? When I said like separating of the two parts, that is coincidence, like for two reasons I am using the same word, but there are two different properties of grass and needle. What we need to do is just try to identify, focus on what is that needle, how it is different from this haystack. There may be millions of grass straws in that, but see, moment I say that I have to separate needle from this haystack or grass, that means now I have made, instead of 1 million or hundreds of million grass and one needle. That is what we were trying to look at. And even Nicola said like Edison would have done it. He would have removed one by one the straws. But now what we have to do, it is 1:1. One is metal, other is property of grass. So how to exploit this difference in the property? You can see this is a sieve, this is a vibration motion, mechanical you can use over here. This is like because this, due to gravity, due to the weight of the needle, it will fall down. Then needle would be heavier than the grass, so grass will float, needle will sink down. Are you getting it? We are just separating it. Biological way, if you just think, if you just leave some biological animal or something like or there, and then it would just stuck, and you can find it out, though it is like non-human way, but this is the way in which one can do. Burn the haystack. If that stack is not required, that is thermal. You heat it to the extremities. Just remember that whenever you are thinking to solve any problem, you just think whatever field is there, first think that it is going towards negative, let it go to negative heating. That means cooling up to sub-zero, maybe much below than that. And in plus side, heat it till the grass get burned. Needle will not burn, and you will get your uh, needle. And in TRIZ, as I mentioned, we exaggerated the thing. So it seems small, but a needle, we should have something in this process. Where is it interacting? Now, right now, I cannot go in detail, but whenever we study in TRIZ, we see that which two parts are in touch, and then go to their properties. And there is a systematic way. If you remember in first slide, I've shown that mental inertia to overcome the mental inertia, one has to walk on the steps. Okay, but what is the advantage of these steps? You do not get diverted, you cannot go on left and right, and in this way you can reach to this solution, so that your needle will be much heavier than this haystack. And for that, who is in touch, this in this? So what we need to do, we may change some of the properties of this liquid, so that needle can be separated out in the quick way, or in very prominent way, needle will be separated. Okay, what are the other ways? You can just see, due to the weight, by the fan you can just blow the grass, but because needle is not light, it is heavy, so needle will fall down. You can just listen, it will make a sound, grass will not. So if you are just pushing it off on the some surface, it will make a sound. Again, acoustic you can use over there. This is actually a challenge which was given in Mythbusters for finding out the needle in the it was on Nat Geo, and these are the two mechanisms these people have used. And practically this is also there like a blueprint which they used over there. So what we do when with TRIZ, we make the solution evident. Once we have done with it, so there were many things which were actually proposed, but then whether it will be useful, how we can actually work on that, are there some variants, are there different ways which may be cheaper, which may be faster, which may be there will be different application solutions for, based upon the different application, and you can just see them. I've just clubbed them for you. And same thing, this is known as winnowing, separating the grain parts from particles from the like its husk, or you can say hay or whatever. Okay, so whenever it is being done, you can see same thing is being done by different principles. Okay, so this is how we reach to the practical solution of a problem. We just do not leave it at a fantasy level, though we started from fantasy level. But it is also equally important to fantasize in the right direction. Okay, I said like he said that any inventive problem is actually to solve a contradiction. Now, what is the contradiction? In any most of these cases, contradiction emerges when two incompatible demands or requirements are placed on the same system and conflict with each other. They oppose each other. Like if I just take this, more accuracy, more complexity. I have a scale, and if the scale is used, what is the it is very simple. You just align with the line or with the object which you want to measure, and you can just find the dimension, but you will not get the accuracy. If you want more accuracy, you will have to use vernier caliper, but then in vernier caliper you have to match it with the two lines and find out the least count and do the number of readings on the scale, multiply and all that stuff, or micrometer, screw gauge. You see, these are very complex. Even if they become like nowadays, these are having like digital readouts, but still these systems are very costly. You cannot compare the cost of a scale with a micrometer, screw gauge. It is too costly about that. So what happens? Complexity increases. If you want more accuracy, what will happen? Accuracy will increase, but the complexity part will also deteriorate. It will not, or in simple terms you can say simplicity part will be deteriorated, and it will not remain simple, it will become complex. I want it to be simple, I want it to be accurate. So this is the contradiction. And what happens? Most of us do not like to deal with paradoxes, and we try to overcome the situation through compromise, trade-off, finding an optimal solution. Very decorated, very highly used word, that I have found the optimum solution. But basically in classical TRIZ we do not have anything like a word optimum, because optimum is actually basic and based on the compromise, and compromise will not give you good results. And it is also stated in other way that agar do logo ke beech mein there is a compromise, so basically what does it mean? It is like both of them are at loss, but both of them are feeling that they are benefited. This is what is there. Now, just by feeling it may not be enough. For that part it may be okay, but in engineering, in a product, in a business, it will not work out. So we should not have. Now how to do it? Contradiction often are very sharp, and then you do not have any scope of compromising. Okay, before that you have to answer one question. What do you see? A horse and a lady. Okay, my question is, are they coming towards us? If answer is yes, write yes. And if you feel they are going away, write no. Are they coming towards us? Yes or no? Just write yes or no. I'll save your time. Time is money. Okay. Please. Okay. But when we list out, and most of the time I have done it, like if I find the average of whatever you have answered, so answer would be any time would be yes and no, isn't it? At one point of time it looks like it is coming towards us, another point it is going towards us. So what would be the best way? Yes and no. Okay, so can you say yes and no at the same time? Next question, can you say yes and no at the same time? I'll show you how to say. What is it? Whether it is no or yes. I'll make it bigger for you. What is this? Yes in no. But I want yes and no. Is it yes and no? Yes. Okay. Now, it is not just something like illusion and just playing mind games and all that stuff. I don't trust in that. I do not have time to waste your time on doing all that stuff. Let's take on a serious note of this. Many a time, systems have to perform in one direction, but subsystems have to perform in different direction. Okay. Now, let's take a simple example. If a current is to be passed through wire, what will happen? Will it cool that wire or will it heat it? If a gas is to be compressed, whether it cool that gas or heat it. Okay, if something is rotating, a part which is actually being rotated, what will happen? Will it generate heat or will it generate some like released heat? It will generate heat. It will generate friction. Perfect. That was my next question. And friction will again generate heat. Okay. What I am saying is the gas is being compressed. That is the coolant. The electricity is being passed. So that are the wires. And the compressor is rotating, moving, friction is there. But if this is put up in a particular manner into a refrigerator, what is the outcome? Outcome is cooling. So what does it mean? The resultant of all the heats is cooling. So same thing, whatever I am showing over here, the resultant of all yes is actually no. So these are certain things which we have to think on. Again, what is this? This is contradiction. Let's go to the another contradiction. A mobile phone, it must be small to provide portability so that I can fit it in my pocket easily, but it must be big so that I can see the screen in a bigger way. Right? I'll not spend your time on giving this holding down your solutions and asking you, because it is very simple. We say in day-to-day life. And what are the solutions? You can have something which can move. Two parts are put together and this can be slide. Here one bus which is very long, and it is good because more number of people can sit in that, but it is bad because it is difficult to turn in the narrow streets. Okay, so what we have done, we have reduced the length but we have increased it. So two things we have made it like this. Pattern, tradition, I told you, like the thinkers of maker of mobile and bus would also think in the same way, but here it deviates. Okay, what is this? Why do you want two screens is a question. Okay, now again, when we look at it, Steve Jobs was the one who actually thought, otherwise people started making it in twofold, threefold. And Steve once said that if I would have listened to the voice of customers, I would have ended up in making bigger and bigger screen with touchpad. Steve Jobs was not an engineer. He did not know that resistive and capacitive kind of screens and everything. He did not know, but he was a visionary. And he made his team make this kind of a screen, which will be like a keypad when it is required to be a keypad and a screen whenever it is required to be a screen. Is it not resolved a contradiction? Same thing here and here. Is it not resolving the contradiction? Yes, it is resolving, and you can give me much more examples than what I am giving to you. So what we need to do is just think of and accept that contradictions can be resolved, but not stopping at that. TRIZ gives us concrete tools, because there are different domains. In this domain this will work, in this domain this will not work, but still how to reach to it. If I just rely on this domain, how would I what I would have done, I don't know. I would have with this some elastic, I would have added one more screen and would have folded it or something like that. Okay, but there I have to be some specific steps. Second thing, whatever he has discovered, is that getting abstract and using knowledge is very important. Three solution patterns are, and it has got inventive principles. Like, what do we mean at going to abstract level? You can see our left brain, right brain, you know many things about these two, and then there would be some situation. This situation is to be analyzed, then we formulate it in a specific problem, and then we find the specific solutions, and further it goes. But what this says, don't go by try and error. You just move your specific problem to the abstract problem. What do we mean by abstract problem? When we say instead of like knife, I do not look at a knife to have a handle and a razor sharp edge, I look at it as something which separates two parts of a fruit or a vegetable or anything else. Or some kind of person would also think of like a knife as to kill someone. So it has got its own uses. But what is your basic objective? I'll just look at it with a positive of that there is something like intruder or an I would say like a bad person who is creating a lot of problem for everyone and he is to be punished. So knife is a good tool over there. Knife is not all killing all someone is not always bad. Of course, at a very different level, it would be. Let's not discuss about that. But just try to understand what I am trying to say. So there are other ways also. Initially, it might have come by just killing by a knife or just killing by a stone, and gradually there were guns and cannons and like all that stuff over there. So these are performing the same, like meeting the same objective, but the phenomena of them are different. And we'll open our eyes by going to the abstract problem. Let's take a simple mathematical problem. The husband is 3 years older than his wife. The product of their ages is 1404. And how old are they? Can you find it out? I'll not ask everyone, but if someone finds it very difficult, can say that, no, I cannot do it. And I'm sure nobody is going to do it. Okay, nobody is going to reply in that way. So what would we do it? We just eliminate husband and wife from that, and we just put it in a simple equation that h into h minus 3 is equal to 1404 or h square minus 3h minus 1404. Now how to solve it? Okay, assuming h is equal to 30, because I want to equate it and get the value of h, other side is 0. So we find it, oh, it is very small, let's go ahead, let's make it big. But then we find it is too big, and then by try and error we reach to the solution. It is not that we do not reach to the solution, but is this the way in which you are going to solve the problem? No. What we'll do, we know that there are set of equations which have got their solutions, and what we need to do is just connect it to the one with which I can get the solution. And in next case, what I need to do is just put all the values of x in a and b and all that stuff, and you get a specific solution. And you can see multiple screens over there because TRIZ gives us multiple solutions. In this case, definitely it may not be, but in actual practice, there will be many times or all the times more than one solutions. Coming to the very interesting part of TRIZ, Altshuler's engineering parameters, which I mentioned. I'll just repeat it quickly that 40,000 patents he studied, and from that he just tried to find out that the inventor, what exactly he tried to do. And he found that he or she has solved one contradiction. And there may be multiple contradictions, but one point of time he has studied one contradiction, and that is why he said like inventive problem is actually resolving the contradiction. Now you can just see what he has listed out: weight of the moving object, weight of non-moving object. Doesn't like we don't feel that what is this, what are these objects and what is the weight and length and all that stuff. But what, at what level he has thought of? At the abstract level. There is nothing to do with the terminologies, whether he is husband or a wife or a son or whatever it may be. These have just come down in this equation, and this equation has got its solution. So it becomes easier. And you know what this triangle is showing? More the lower level of abstraction you are, more time it would take to reach to the solution, and higher you reach, quickly you can reach to the solution, because at a higher abstraction the solution is very evident. That is again a great finding by Altshuler. So coming back to our point, he made 39 engineering parameters. You know what very interesting thing is that he did it in 80s, or you can just consider in 90s also he did it. And in that era he had got the access of only patents of Russian government. Forget about only navy, he might have got air force, army or other things also, but only in Russian region. But at a later stage people tried to work upon this, and just remember that in Altshuler's time, there was hardly any computerization. There were no IoT, there were very less of the electronics and Bluetooth and all that stuff were not there. So how these basic principles will solve our problem? We need some different engineering parameters, right? People also thought in this direction, and they worked upon that. With the advent of new like artificial intelligence and like keyword processing, finding out, and high speed computers and everything. And they had to their access patents all across the world, because you can also Google many patents just by like a Google patents, and there are many other websites also from which you can get the access of this, and at least you can understand how he or she has solved the problem. Okay, you can make the contradiction, and same thing was done not for one time, it was done for more than three times. Three times is recorded. Okay, but important thing, they could not add even a single engineering parameter. 39 remained 39. Of course, they added some classes within them, and that too due to this electronics and AI and all that, whatever is going on nowadays, with whatever the intelligence they have, artificial and high intelligence. It's not to be demeaned. So why this was possible? It was possible because Altshuler did it at a very abstract level. And that is why anything at an abstract level, as I mentioned, is very clear, very simple. Okay. So you just can see, you would have read it also, or you can just Google Altshuler's matrix or engineering parameter, or you can send me a mail also. I can just respond. I'll share all this literature with you. Okay. Now, from this, he found 40 inventive principle. He just thought, looked at it, that these two, I'm just taking a like I can show you here also. This is the contradiction matrix. What he did is he put all these improving factors on one, as I have shown you on the accuracy part, right? And he put all the worsening parameters, okay, on this. And what, of course, this and this will remain same, this and this will remain same, and you will not get anything over here. And he just started putting on those principles whichever he found out through this. Some of them solved some problem by copying, some of them solved by self-service, some of by like color changes, homogeneity. It needs some practice, it needs some guidance, it needs some training, it needs some like conscious efforts to put on this. But still, you can just go at a very simpler level and still you will get the results out of this. Okay, so when you find these numbers in this contradiction number, what exactly is this? This is one engineering parameter, this is to be improved, this is another one which is to be worsened, and when you come down to this, you get some solutions. It is 15, 8, 29, 34. If you just look at it, 15 says that dynamicity, 21 says convert harm to benefit. Okay, I don't know, 21 was not there. 8 is counterweight. Okay, 29 is use pneumatic hydraulic. And see, while doing it, what you are actually doing is you are using the knowledge which is actually there and which is a proved knowledge. And in this case, for your one contradiction, you get only four different direction or inventive principles to be used. While I say only four, I also say, if you remember, that TRIZ gives you divergent solutions. Each one of them would be capable of giving you 4 to 5 different solution directions. And you see, instead of getting huge number of ideas, what we are doing is we are creating huge number of solution directions. So if there are 4, so around 16 to 20 different solution directions you may be getting in. And then you can always sort out the best, because there is nothing best in TRIZ or everywhere in the world. Because if you say that you are best, means you are stopping your growth. You are sitting on the top of a hill, which is a like cone, top of the cone. So there is no other way. Either you have to be balancing yourself on that position, or you can go down. So you should never think that we have to reach to the best. Anything cannot be best. Nothing can be best. You can just be better and better and better. It is a continuous journey. So are you ready to solve a problem? So we'll be solving a problem of nothing less than Boeing. Okay. Problem was that this engine of this Boeing had to be made like what is it? The capacity of the engine has to be increased. Okay, powerful engine has to be installed. That was not an issue. Issue was this air intake. If the engine becomes bigger, air intake has to be bigger. And what will happen if it becomes bigger? There is very less clearance, and when it flies and when it lands, at that time there may be chances that it may be just hitting it down to the ground and accident may uh, take place. Yes, we need to design the propeller. So I've just shown you how like less ground clearance is there. So now what is the contradiction? Length of the moving object should be worsened, means it should be small, and area of the moving object should be high, means you this it should not come down, but at the same time it should be bigger. Are you getting it? Many a time, just framing the contradiction in the right words can give you a solution direction. Because when I discuss, many of the participants immediately come up with the solution just when I state it in that way. Okay, and that is how TRIZ is better. In TRIZ, we are very specific about the grammar of all this stuff, how to state and how to use it in minimum words and all that stuff. So my point is clear. Length of the moving object is to be reduced so that there will be more ground clearance, and area of this is to be increased so that there will be uh, like better air intake through it. And what were the solution direction from this contradiction matrix were asymmetry, spheroidality, dynamicity, and mechanical vibration. So what we'll do for the simplicity and constraint of the time, we'll just take only one asymmetry, okay, out of them four. When we look at asymmetry, I have shown you a purposefully this uh, cartoon wherein, because this fellow is lean small, so we need only one wheel over here, but this she is a bigger fat, so we need more support from this side. So this is the asymmetry. Are you getting it? So now we are habituated to see things in a symmetric way. Before going to our Boeing problem, as I mentioned that the problems can be solved in different domains, so I'll just take the opportunity to explain it in the way this is also solved with asymmetry. What is the problem? This is an umbrella. One person is getting very less space because this much of portion is actually being waste. He can protect himself only in this direction, in this area. Okay. And then when the air blows, because it is of this shape, it will just take it off. Okay. So asymmetry, when you use, see, just a principle of asymmetry. What you have done is you have just tried to find out. Now, in this case, it was very evident, it is very visible, it is very clear just looking at it. What is symmetrical? This is symmetrical, let's make it asymmetrical. And obviously when you think of making it asymmetry, so you will be having it more on one of the side. You can see actually the material whatever is being used is same, but then what you get two advantages: better protection from the rain, at the same time it will not be blown off by the wind. Similarly, when you pedal a bicycle, the energy whichever you are using is actually used in only this direction. You might have realized it. Then by the time you push it by right leg, your left leg is ready to do it, and that is how we run it. Again, can you use the asymmetry principle and increase the efficiency of that? Same asymmetry. So what will you do? Make something which is symmetric as an asymmetric, though it is a bit exaggerated in this case, but many of the new bicycles, particularly the high-end bicycles and racing bicycles, have this kind of sprocket to move, and this more larger duration you can apply your muscle power over there, and you can attain a higher speed through this. Okay, so same thing. How to solve this? Any answer? Okay, you can just squash it. You see, this length remains same. On what we have done, we have just squashed it and it is increased. Okay, area is increased, but the length is reduced or remains same. And this is a problem which was solved by TRIZ stream for Boeing. It is a live problem. And see the mental inertia. Again, at bottom it was being used, but at the front, again it was like this, and later people realized and it was made like this. Of course, these are kind of fighter planes and all. So coming to our Centris innovation roadmap, what is it? Now, due to the paucity of time, we do not have enough to discuss on this, but I would like to emphasize that there are 8 tools just to identify a problem, and you can see one tool trimming at the time of the problem identification itself. Okay, and then for problem solving, we have different 7 tools, and for concept substantiation, we have all 4 tools. It will take like a long time to explain all of them, but once we are familiar with this, it reduces the time of finding out the solutions. Okay,
So I'll share one case study with you, and then go ahead. Like voice of customer, as I shared with you regarding this Steve Jobs also, many a time we perform the voice of customer with market research, field interviews, conjoint analysis, focus groups and all. But people, why this does not work? Because people are not good at identifying their needs. Okay, why? Limitation of market survey. People don't know what they don't know. They, even if they think of, sometimes fantasize, but they may not ask for some advanced product features. And that is why we have in TRIZ a voice of products. What we do is simply listening to voice of product may not be enough, and there has to be a sweet spot between what customer wants and what is the voice of the product. Based upon that, we make the actual MPV. What is this MPV? It results in defining innovation. And how do we define innovation? Market available significant improvement along at least one main parameter of value. Are you getting it? Customer does not know what he does not know, but the product knows. Okay, but what product knows and what customer knows is the best buy, and you have to do a practical innovation. That is why I said, like, incremental and breakthrough. TRIZ makes breakthrough in an incremental way and less risky and more rewarding. You remember the first graph which I have shown. I'll directly jump to one of the case studies. It is a real case study of Panasonic. Panasonic was losing market share. It was highly saturated and competitive share market. The point was like a very high price because Chinese market were there. Panasonic shares were sold in 200 or $250, while like Chinese and other marketers, manufacturers were selling it in 150 plus dollars, and the performance was marginal. That was the challenge. Okay, I don't know why I'm going back. Okay, so when we listen to the voice of customer, they said like, we want shaving effectiveness and cleanliness and skin protection, and these were actually being satisfied. With the TRIZ tools, when we did the market niche analysis, it was found that frequent travelers are there, elderly or disabled like Parkinson disease with hand tremor people are there, people with fast growing hair. It is found that 8% of the people have hair which grows by the evening, even if they have shaved in the morning, and people may feel that he is not shaved at all. So they want something which should be on the go shaver. And how did we convert it into MPV? Like, this is the product demand, and then what is the customer? Size of the shaver, weight of the shaver should be less, absence of the need of charging, so that frequent travelers need not have hassle of carrying chargers and like a lot of wiring. It should be low cost. And see the solution: compact car side shaver that can be used on demand. The price is $19 to $54. And when we ask the customer that if we can offer you this kind of a product, how much are you ready to pay? You know what they said? We are ready to pay to like $250 to $300 instead of $200 product. And what is the price in which it is sold? And again, it is protected by over 7 8 like different patents, so that people cannot use it. And see the impact: 50 million annual revenue just by this product, which was not being sold at all. This is a second real case study which I am sharing with you, and this is what I have shown you earlier. So I'll just skip these things, and because we are on the verge of finishing, because most of you are from academics, so I'll let you know that what is the strength of TRIZ when it intervened and handheld with the General Electric. See the number of patents, how it has increased. From this intervention, Samsung, how it has increased, and consistently you can see this. Procter and Gamble, it has gone like this. Over a million of people are being trained in Fortune 500 industries. These are the products. These are the partial list of the clients. These are the, if you have not heard about TRIZ in academics, so there are more than like 200 books in 40 languages, more than hundreds of university teaching it. You can see the result of one of the training program. 6 students, one problem was actually solved, one new product development was done, and in that you can see the trimming strength. 35% of the components in that system were reduced. Cost reduction was about 40%. Solutions generated were around 37, and potential patents were 1. And in these 3 groups, you can see this was the average of that. Many universities studies this. UG, PG, PhD projects are being used with these entrepreneurs, startups.
generating patent idea, patent publication. Even in education, we are using it, and it just, you know what it is. It is Bloom's taxonomy. We are working with trainers, embedding in curriculum, project, trizathons like a hackathon and all, need-based training, tailor-made handholding, and by implementing this in education, this pyramid actually becomes inverted, and people start learning from the creating, and they do not need to have remembering and understanding of the customers, because this is inbuilt, inherently done in this process. These are the institutes which with we have had some direct training programs in national as well as international level. You can see over there, these are the universities implementing TRIZ. Just a few I've just tried to put up. You can see all these testimonials on our website, and these are the organizations with whom we are working in in India. These are educational institute as well as these are regarding academics. These are ARM, Vishay, Fleetguard, and these are the industries wherein we are actually providing live consultancies. And this is about what is Gentriz. Headquarters is in USA. We have technical center and research lab in St. Petersburg. We have offices all across the world. We have 30 plus professionals working for us. We have very interesting thing that 8,000 scientists in 24 countries, wherein I have given you an example of Panasonic. In this Panasonic, what was the biggest challenge? It was a flat motor. And this flat motor had made, you might not have seen, at least I didn't see before that, a flat motor. Most of the motors are cylindrical shape, and due to that flat motor only, this shaver could become so small. You can just go on Amazon or something, Flipkart and all, just try to search um, on the go shavers Panasonic, and you will get that. And I can guarantee it because I'm using that product, and since last 3 months this what you can say, it has got two AAA size battery, small batteries, and it is still working. Of course, they say that it runs for 1 month, I don't know. And these are the takeaways. I didn't want you to just leave with some uh, like preaching and all. These are the things you can just take a snapshot of that. Matchem IB I have already shared with you. You just try to use those things, and definitely you'll get good results. And this is all. These are my contacts. Feel free to contact me, or just visit trizassociation.org and or trizasia.com. These are our website, and I am open for answering your questions if you have any. I just try to meet the given time to myself.
Hello.
Yeah, ma'am.
Good afternoon, sir. This is Dr. Tanuja Dupe.
Yes, ma'am.
Sir, there are few questions from the participants. The first one is, how can trees be added with problem-based learning?
Actually, TRIZ itself is a problem solving tool. So any kind of problem based learning will have a very perfect match with TRIZ, because TRIZ basically starts from the mental inertia. I could not share more, but I tried to put so many tools within this demonstration that you can at least appreciate that how it can work. I'll just share one of the example in one of the institutes only, education institute. I'll give that example. We were doing a workshop, and in that I posed one of the tool, and while teaching it, I just told them, let's take some simple examples and we'll sort out the solution for that. And within a group of 4 and 5 people themselves, with the input of hardly half an hour, I trust me whatever I'm saying, within a half an hour people could generate multiple solutions for these. At first place, it makes us understand that there is a problem. That's what I'm saying. When we try to find out the contradiction, we actually understand the problem. And I have shown that there are 8 tools just to identify the problem. So that is the strength. And what it has got is basically, it has a systematic way. You cannot miss it. It goes in that way.
Okay, thank you, sir. And the second question is, how can trees be used in intellectual property use?
Ma'am, I'll just give you an example. There is, you can Google his name, Sergey Ikovenko. He's a TRIZ master, and he's working with Hyundai Motors international level. And at international level, his responsibility is to train their employees, and you know what, circumvent the patents which are actually filed or
published or procured by other car manufacturer or whatever it may be. So this team is actually just getting maximum benefit of those through not infringing their patents, and that is the strength of TRIZ, because as I've shown you this tool TRIM. So if you add some component in a system, you may not get a patent, but if you reduce the number of system or subsystems into a system, so you may be getting, if you are getting the same functions, in that case the product would directly become patentable, and TRIZ is known for generating ideas which are patentable. That is
Thank
the
you.
biggest strength of TRIZ.
Okay, nicely, sir. So definitely, sir, whatever links you have shared just now, and whatever the topics which you have discussed in your expert talk, those will be definitely helpful for the audience also. So from Department of ENTC, Rajarshi Shahu College of Engineering, I, Dr. Tanuja Dupe, I am very much grateful to Dr. Sandeep Wankhade, sir, for delivering his expert talk on TRIZ roadmap to innovation. And I'm once again very thankful to you, sir, for sparing your time. And in future also, we will be expecting same kind of collaboration if we are organizing the topics which is of your interest. Thanks a lot, sir.
Thank you so much for giving me this opportunity, ma'am. But please let me not be at the level of just making the TRIZ aware. Let's work on somewhere wherein we can actually learn and practice it. And thanks for calling me as an expert, but I am still learning TRIZ. And I'm really fascinated as I started with it. It is more you learn, more you get involved in that. So take any opportunity or every opportunity to learn TRIZ. And you cannot, no one can stop from doing it. You can just Google it. There are many resources. You just start learning TRIZ. That is really important and very useful. That is all I would like to share.
Sir, just wait a minute.
Thank you, Wankhede sir. This is Dr. Shailaja Patil.
Yeah, ma'am.
For another wonderful session.
Thank
All
you.
audience attendees will surely take benefit of it. Thank you so much.
Yes, ma'am.
Now, over to Pranav Chipalkatti, sir. Sir, do you want to do some announcements?
Yes, ma'am. Participants are requested to join the session on Monday at 10 a.m. Thank you.
So the session is over?
Yes, sir. Yes, sir.
Oh.
Thank you, sir.
Thanks a lot, sir. Yeah.
Here is Dr. Swati Visikar. Thank you very much, sir, for sparing your valuable time with us.
No, ma'am, I am always available.
Yes,
And
sir.
as I said, like I love speaking on TRIZ, so that is not an issue.
Yes, sir.
Yeah. Have a great day.
Yes, sir. Good day.
May I leave now?
Yes, sir.
Yes, sir.